A ruler could help. Since we're making a cum frequency graph, that's what the y-axis would be, cumulative frequency. The biggest number is 69, so I'll go by tens. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 60, 65, 70. I might only mark every 10. So the first point is 0 on the x, 8 on the y. The second point would be 2, 11. The third point would be 4, 20. And so forth. 6, 31. Again, we're trying to find the time after 28 minutes. So this one was 6. I'm sorry, this one was 6. 6, 31. This one is 8, 43. $10, 50. 12, 55. 14, 63. And 22, 69. And then we connect the dots. It is not a best fit line, so it should not be linear. Then we will use the graph to answer the following questions. First one, find the median. Now the median is the 50th percentile. There are 69 numbers, so we're going to go 69 times 0.5. Now you could use the n plus 1, but usually with percentiles, we just talk about the 0.5. So there is another formula, but either way, these are estimating the answer anyways. So if you use the other method, it's not going to change your answer much. Maybe 1, but as long as you're showing your work on the graph, it doesn't matter. So 69 times 0.5 is 34.5. So we want to find that term on the graph. So we draw lines from 34.5 term to find where that median is. So 34, and like I said, if we use the other formula, it would be 35, so it wouldn't change really anything, hardly at all. So we're going to go across and then down. Now I've done this many times over the years, and I get different answers every year, or most years. This looks like it's around 5. Now remember, that's the time after 26 minutes. All right, so I need to add the 5 with the 26. All right. Whoops. I was going to say that did not look right at all. I was just checking to see if you guys were paying attention. Make sure you go to 34. That was 24. 34 is up here. That looks like it's about 6. Again, we want to add 6 to 26 to get 2 hours and 32 minutes. Now in my notes, I have the answer at 2 hours and 34 minutes. So my graph probably wasn't drawn great. That's fine. The work here, drawing the dotted lines, will get you the credit. So we add 6 to 26 to get 2 hours and 32 minutes. So like I said, my answer in my book was 2 hours and 34 minutes, but based on my graph, which wasn't drawn great, I have 2 hours and 32 minutes, which is fine. Next question, how many competitors, all right, so how many people, the number of competitors who finished in less than 2 hours, 45 minutes. So 2 hours and 45 minutes, if we do a little arithmetic, 45 minutes minus 26, that's 19 minutes after on this chart. Because remember, here's 2 hours and 26 minutes. We need to find 2 hours and 45 minutes. So that's 19 minutes later, which would be right here. So I'm going to again make my dotted line up and over. Again, not drawn great. On the IB test, they would give you a grid, so things would be more even. But based on my estimate, the answer should be approximately 65. Again, in my notes, I have 62. So. Next question, percentage of competitors who took more than let's see if I can squeeze this in here, 2 hours, 39 minutes. So again, 39 minutes is 13 minutes after 26 minutes. So I got to find 13 minutes on the x-axis. 13 minutes is right here. So we're going to go up and we're going to go over. All right, so I have 54. Now the question is, how many took more than that? So 54 are under that. So I need to figure out how many did more. Well, there were 69 people. 69 minus 54 is 15. And since I want a percentage, I have to take that number over the total, which is 69. Change it to a percentage, we're going to times it by 100. Use my calculator. 15 divided by 69 times 100. And then we're going to round to 3 significant figures. So approximately 21.7%. In my notes, I have 26.4%. So again, it's based on your lines that you drew. 2 more questions. Let's see if I can squeeze them in down here. Letter F. Time taken by a competitor who finished in the 20th percentile. So again, if you remember what I said, the higher time is the better score. So finishing in the 20th percentile is not great. All right, there's a few ways you can do this one, but we basically want to find out where that's located. So there are 69 total people. If you finished in the 20th percentile, you're going to times it by 0.2, which is 13.8. So we want to find the 13.8 person on the graph. You could round to 14, but it's not going to change your answer. So whether I'm at 13.8 or 14, should probably get basically the same answer. So I come here and down. Looks like 3. Again, it's after 26, so I got to add 3 to 26 to get 2 hours 29 minutes. In my notes, I had 2 hours and 31 minutes. I think in my notes, I might have taken the average of the 2 times, which is fine. Like I said, it's more based on your lines that you drew. So if you took the average of these starting times, that would change your answer slightly. And it seems like I'm a little higher on my answers before. And then the last question, let's see if I can squeeze it in here. Time taken by a competitor who finished in the top 10%. Time taken by person in top 10%. Now they didn't say percentile, so being in the 10 percentile is different than being in the top 10%. So if you're in the top 10%, you are in the 90th percentile. All right, so there's a little tricky with the words here. So you're in the 90th percentile. So you want to multiply by 0.9. So again, 69 times 0.9 is 862.1. Sure my math is right. Yep. Okay, great. Again, you could round that down to 62, but it doesn't matter. So we want to find the 62nd person. So again, we're going to draw our line. Again, that's 17 minutes after 26. So 17 plus 26 would be 43. In my notes, I have 2 hours and 46 minutes. And again, that's probably if you take the average, so my graph would have been a little different. And that's the it for that graph. There is one more problem that we need to do from this section. And that's matching graphs with tables and phrases. All right, so we are given graphs. Here's one graph. Here's another graph. Here's another graph. And we want to match that with tables. All right. Let me just put these tables in some order here. Hour and frequency. 1, 2, 3, 3, 4, 5.2. 1, 2, 3. Here's one where the frequency is going down. And the last one. Oh, that should be a Q. 1, 2, 3, 3, 3, 3. Again, these are cumulative frequency graphs, where the table just says frequency. So again, they're trying to trick you a little bit. And then they got 3 statements. Increase, slower, and slower rate. Increase, constant rate, and increase, faster and faster rate. So we need to match these up. All right, so again, the key here is making sure you understand this is a cumulative frequency. So this linear one, if it's cumulative, must be going up the same amount each time. So it must have a consistent frequency, which would be this one. So I'm not sure how I want to do this, but that table goes with that one. And since it's increasing at a constant rate, that one also goes that direction. Now the two that are a little bit harder, I think, are maybe these two. This one is increasing at a much faster rate. If you think time is your x-axis, all right, where frequency is always your y-axis. So it's not taking very long for the frequency to increase. So it must be increasing at a faster rate, and the frequency must be increasing too, which would be this one right here. So frequency is going up. This might get a little sloppy here. And it's increasing at a faster rate. The more vertical the line, the faster that it's increasing. Where this one, again, if you think of it, time and frequency, look how much longer it takes to get there. It's taking a long time to get there. So the frequency is decreasing, and it's going at a slower and slower rate. So there, slower and slower rate. This is pretty sloppy, but going in there. And that's the end of the 20-point E. All right, 20F was supposed to be divided into 2 sections. And I'll just put it all together since I'm putting all these lessons together. We're going to look at the other 2 spreads. So far we've looked at range and interquartile range. Now we're going to look at variance, which we will not spend much time on, and standard deviation, which is a little bit more important. All right, let's recall that if we have a bunch of data points, x sub 1, x sub 2, x sub 3, and so forth, to x sub n, that has a mean of x. And x sub 1 minus the mean of x measures how far x sub 1 deviates from the mean. Therefore, the variance of a sample of n data points is as follows. To be honest, this formula not extremely important to know, but it doesn't hurt. The initial value is usually 1. N represents how many data points there are. This is S sub n squared. We take the sum, that's what the sigma means, of x sub I, which is all the data points, the difference of all the data points from the mean squared, and then we divide that by n to get an average. So we subtract all the data points from the mean, square it, and then we divide it by n. Again, we're not going to really use this formula, but this is more of a proof. X sub 1 minus x sub, I'm sorry, the mean of x. This is x sub I, my fault. X sub I minus the mean of x squared. Why we square it is the square ensures that each term is positive. So if we're trying to find the distance, we want to make sure that it is positive, because we can't have a negative distance. The square ensures that each term is positive. If this value, all right, I'm just going to redraw that. Oops. Don't need that line there. It's just the same thing I'm writing here. If this value is small, what that means is most of the data is close to the mean. Dividing by n gives you the average again. So it gives an indication of how far on average each data point is from the mean. Now, we don't use variance hardly at all. That's why most of you may not even have heard of that, because when we talk about a distance, the units that we use are singular, like centimeters or meters, where variance, if we look at the formula, is squaring it, so that would be square units. So usually we don't do that. So how we get around that is we do what is called the standard deviation, which basically square roots both sides. So we're going to kind of square, not kind of, we're going to square root both sides, and that would be the standard deviation. So if we square root that, basically we got S sub n is equal to the square root of all this stuff. All right, I'm going to write a little small here. so including the division. So that whole thing is square rooted. This again is called standard deviation. So that's the one we're going to be doing in this class, is standard deviation. There is one question dealing with variance, but it's basically how do you get from the variance to the standard deviation. All right, so standard deviation is, like I said, more commonly used. If we're talking about weight, we like to say kilograms, not kilograms squared, which is what it would be in variance. We use the singular unit. It is a non-resistant measure of spread. It depends on the mean. So outliers, or very high or low data, can make it useless. So if you have one number that's very far away from the rest, standard deviation is not used as often because it's not as good. The better method would then be the IQR, or percentiles. That's a better tool for measuring spread if data is skewed. All right, so let's do an example. Find the mean and standard deviation for each. Here's our data points, only 5 of them. All right, to find the standard deviation, we make a chart. We list the numbers. Now if we look at the formula, first thing we should do is figure out the mean. I'll do that off to the side. We average them all up, add them all up, and divide by 5. 10, 24, 35 divided by 5 is 7. So the average is 7. Now if we look at the formula, first thing we should probably do is subtract each point from the mean. So we're going to take all these data points and subtract them from 7. So 3 minus 7 is negative 4, 0, 6 minus 7, negative 1, 1, and 4. Now you can see why we are squaring it, because we don't need these negative values, because you're going to end up canceling each other out, whereas we want to know the distance from the mean. So we square each of these, so they all become positive or 0. So we squared all these numbers. Looking at the formula, we should take the sum of that. Ooh, I don't have a lot of room down here. Sum 34. story about that. So the sum of these numbers is 34. And then after that, we're going to divide that by n. So we're done with the table. So we can go to basically the formula here. So the sum of this, put all these other things in here. All right, so the sum is 34. There are 4 data points. We use our calculator. Square root of 34 divided by 5. We're going to round that to 3 significant figures. 2.61. So what that means is each data point on average is 2.61 units from the mean. Let's do the next example. Same directions. But I want to show you a different way of how to get the answer. So here's our data points. Sometimes IB will say you have to fill in the table to complete it, but if they don't, we can use a graphing calculator. How we're going to do that, let's see how I want to do this. Let me put the directions down first. We're going to hit stat. Actually, I'm going to do this at the same time. Let's see if I can make this work. So we hit stat. Let's see if I can put that right there. I'll just do that. Wish I was left-handed. Enter. Oh, I can put it over here. How about that? There we go. So we go stat, enter. We want to get all these data points out of here. Actually, these are the data points I wanted, but let me just redo it. So if we want to get rid of the data points, we got to go up arrow, clear, enter. Same thing here, up arrow, clear, enter. And then we enter all the data points. 2, enter, 3, enter, 5, enter, 4, enter, 6.